Our next problem asks us to again convert a fraction to a decimal. So over here we're expressing 5/12 as a decimal. 5/12 as a decimal. So right over here, 5/12 as a decimal. Again, the easiest way to do this problem, or to do those kind of problem, is to use line division. Line division. Cool. So again, we are trying to divide. Again, 5/12 is the same as 5 divided by 12. And over here, we're just going to do the line division. Again, 0 times 12 is 0, and 5 minus 0 is 5. In order to maintain the value of 5, we just put a dot over here, so it's 5.00000, which is the same as 5. So over here we have 5 again, and we just drop the 0 down. And the biggest number we can put here is actually 4. And 12 times 4 will be 48. 48. Perfect. And this is and the remainder of 15 minus 48 will be 20. And the largest number we can put here is 1. So that would just make 1 times 12 equals to 12. And 20 minus 12 would just be 8. Again, we drop the 0 over here. The 0 goes down. We drop the 0 down to here. And we need to try. So now we can't directly see what our biggest number would be. So let's just try some numbers out. First, let's try 7. 2 times 7 is 14. So we write the 1 here and write the 4 over here. And 1 times 7 is 7. But we're going to add the 1, so it's 84. This number is larger than 80, so 7 is too big. Now, let's try 6. You know what? Let's do 5. Let's do 5. I'm just going to illustrate you something. So we have 80, 2 times, and we have 12 times 5, 12 times 5, 2 times 5 is 10, 1 times 5 is 5, and that would give us 60. So 80 minus 60, we can just, you would think that we just do here, and we would have a remainder of 20. However, the remainder is larger than the 12 over here. That means that we can actually do 6 instead of 5, because another 12 can fit inside of the 80. And the remainder we need to have must always be less than the divisor 12 over here. So the remainder we have over here for any of the divisions must be less than the number over here. Okay, so we know 7 is actually too big. So our 5 is too. We know 7 is too big, and 5 is too small. So we know the answer is 6. So we have 12 times 6 over here, and 2 times 6 is 12. 1 times 6 is 6, but we have plus the 1 here, so it's 7. And the remainder is 8 again. So we have 80 again. And what number should we put here? It's actually 6 again, and it's just 72. And again, we have the remainder 8. So you would drop. Again, we have the remainder 8. So again, you would drop the 0 and put the 6 up here, and this goes on forever and ever. So what we do here is that we know that the decimal that we're converting this number to is actually goes on forever. So in this case, we just put a horizontal line on top of the number that's repeating. In this case, the 6 is the number that's repeating. So we just write our answer at 0.416 with a horizontal line on top of the 6, symbolizing that the 6 kept repeating infinitely. So over here, the decimal 5/12 is equal to the fraction 5/12 is equal to the decimal 0.416, where the 6 repeats infinitely or indefinitely. Okay, so this is our solution for this problem. Let's look at the sample solution they provided. The sample solution over here, they also use the long division method because that would be the most straightforward method. And yes, they also had the 0.416 repeating, or like the that the 6 is non-terminating. They could have just put the 6 on the first 6 over here, but I guess putting it on the other 6 is also okay. It's also correct, but it's not the convention, because conventionally we just put the bar on top of the 6. Because if you put the bar on 6 as a sample solution, it also symbolizes a repeating 6. That means just the 6 would repeat non-terminatingly. So it would just go 6, 6, 6. But if you just put the bar on the 6 in front of on the third number, on the 6 in front, it also means 6 repeating indefinitely. So this would be the same, but you can write one number less, which would be better because mathematicians are lazy as us. Or humans are lazy, I should say. Okay, let's say the solution is correct. The solution is correct. Great job. Great job. Moving on to our next problem.